Okay. Good morning to everybody. My name is Saverio Cambioni. Our subsystems and our system requirements. And finally, I will introduce our preliminary risk analysis and our future action plans. Let's start. The first problem I would like to talk about is air pollution. I'm sure that you know how it strongly impacts both our life and environment. Many satellites can be used in order to monitor the most critical areas in the world, as well as to alert in case of toxic events. And what about climate change? This is a topic often abused, without a real desire to make an effort, and climate change and global warming are very dangerous, not only for our poor polar bear in the picture as you can see, but also for us, for the environment, and for our cultivations. So satellites could help us in order to monitor the situation. Yes, we agree that this phenomena can be monitored, but how? There are several atmospheric parameters that can help us. For instance, the level of aerosols and dust scattered in the air can be directly connected with both global warming and climate change. But other parameters are less intuitive, but not less important. For instance, analyzing the cloud features and the surface characteristics, as well as analyzing the top of the atmosphere albedo variations due to the changes in atmospheric compositions, are activities of paramount importance. But are we reinventing the wheel? Absolutely not. There are many existing solutions nowadays, but one by far inspired us most is Terra satellite. Terra satellite was launched by NASA in 1999 and has many sensors, as you can see. But for us, the most important one is MISR, the multi-angle imaging spectrodiometer. Terra satellites uses old technology and it needs huge capital to be kept alive. Today, the trend is cheaper, faster, better. Numerous constellations of CubeSats for Earth observation were born in order to provide higher resolution imagery, but only with nadir pointing capability. To sum up, major measurements are not sufficient for accurate analysis, and data has low reliability due to the wide time gap between two consecutive angular measurements. For these reasons, we need the CubeSats information flight in order to provide higher resolution and reliability in data. Thus, the best synthesis is HORUS, the celestial cast. HORUS of nadir observation capability provides significant enhancements in terms of spatial resolution and visit time for shotted images. Our proposal for a new system of global environmental monitoring is a technology able to provide multi-perspective and multispectral imagery with a low-cost constellation of CubeSats. As you can see from the slide, our constellation is composed by 4 GU CubeSats. And the striking point of our mission is that now we can simulate the technology of MISR, but in a synthetic way. The strength, the uniqueness of our project is that now we can obtain similar data to MISR, but reducing weight, meanwhile gaining more flexibility. Our system is also scalable. In fact, as you can see, is based on technology very easy to be commercialized and reproduced. We can put on orbit more Castor Falcons in order to increase the amount and the quality of data. The name Falcon came from the fact that Horus was a god in Egyptian mythology with the shape of a falcon. And to last, but not least, our system is complementary with other Earth observation constellations, such as ESA Sentinels. We can work in synergy with them in order to increase data flow and the amount and quality of data. Let's move to our main payload and its feature. In order to obtain more robust and reliable data, we need multi-angle views for optical sensors. Our payload is called the synthetic minimizer. It's called minimizer because we want to reproduce miser technology, but in a synthetic way. In particular, we can also acquire nadir pointing imagery. Nadir pointing imagery is very, very important because it can be used for the comparison with of nadir imagery. And so we can reduce the error caused by the distortion due the surface topographic effects. As you can see, as you can see, each direction has a specific application. Moving to different bands, minimizer can acquire both radiometrically and geometrically calibrated imagery using 10 cameras in 4 spectral bands. Each band has a specific application, as you can see. Okay. This is a double entry table that summarizes the correlations between spectral bands and different cameras. The proper monotone color band, the raw color band, is the proper application of the the monotone color raw is the proper application of the band, and as you can see, the nadir pointing is used for the comparison. Okay, let's move to our system requirement. Our optical sensors has specific limitations in terms of diurnal sampling and specific constraints in terms of cloud fraction statistics. Moreover, we need a strong attitude and orbit control system because we will experience a strong decay due to the atmospheric drag, which induces also torques on the CubeSats. I will explain you better this aspect in the following steps. This is our orbit design. We choose a sun-synchronous orbit, and the most important figure of this slide is the shift into anomaly. It has been calculated considering both collision avoidance and the functionality of the orbit. This is our mission segments. Our satellites will transmit in telemetry data to specific ground stations, for instance, Medicina and Terra in Italy. And ground station will provide the users with both raw and filtered data. In particular, our users are everyone which is interested in the topics I mentioned at the very beginning of the presentation, so universities, space agencies, and private companies, for instance. As far as our communication channel is concerned, we think to use an X-band transponder for the downlink and an S-band channel. Our system is very flexible also about the launch segments. An injection on orbit by expulsion from the ISS is also a good solution. Precious data obviously needs a very good communication channel, and this is our preliminary link budget. We can guarantee at minimum a data rate of 1.1 megabits per second. Okay, let's move over to our subsystems. So the most important ones are reported in the slide. I will move to the most critical part of our mission, which is the orbit decay. The orbit decay is very important, and so we perform an analysis in order to understand how strongly the drag impacts on our satellites. And this is the result. We experience a daily decay of 80 meters. So we need an orbit control system in order to avoid this situation. Moreover, the decay it will be different from one satellite to another due to the fact that each satellite will have a specific ballistic coefficient. This is our idea for attitude determination and control system. In fact, as I mentioned before, drag also induces torques on CubeSats, so we need to minimize the relative pointing error for a good communication channel as well as for the observation. And so we collaborate with Hyperion Technologies in order to design and understand which could be the best solution. And this is one all-in-one solution with whose datasheet is now reported here. Okay, as far as our power management is concerned, we plan to add two deployable solar panel to the ordinary solar panel of each CubeSats, and in order to gain more power. And we plan to use triple junction solar cells, triangular solar cells with an efficiency of 30%. We follow also the guidelines by ESA about the orbit at the end of the mission of each satellite, and so we plan to add a drag sail provided by MPC Space Mind from Bologna, Italy, which will be tested on Ursa Major QB50 CubeSats, and in particular it is made of a polymeric material with shape memory properties. As far as the structure is concerned, our drives are optimization and integration compatibility, and we plan to start from an aluminum monolithic structure and to develop the structure with a SMERS process. Let's move to the very end of our presentation. We perform a preliminary risk analysis in order to validate our project. As you can see, the most critical point is the downlink data loss, and we think to prevent it, adding extra memories on board on satellites. Let's move to our future action plans. From a technological point of view, we plan to increase the spectral range and to double the refinement spatial resolution. Moreover, we are creating a network surrounding our project in order to support it. We are collaborating with our research providers in order to develop the main payload and the main subsystems. Moreover, we are establishing several partnerships with other Earth observation constellations in order to increase the amount and the quality of data, as I mentioned before. As you can see, we have a wide outreach program, and La Sapienza, University of Rome, and our department strongly support our project. Obviously, we need money to support our project. So we plan a wide fundraising campaign on Kickstarter. Moreover, both Italian companies and international firms. These are our advisors, Per Mathieu and Gordon Campbell from ESRIN ESA, Center for Earth Observation, and Fabrizio Pergentili and Fabio Santoni from La Sapienza are our university coach. We are a strong and motivated team, and we are the right team for this project. Here we are. Saverio Cambioni and my colleague Alice Pellegrino, then Federica Angeletti and Federico Curiano in the audience, and Federica Zaccardi and our designer Martina Cesarini. Let's observe the work together with HORUS, the celestial cast. If you have any question, please do not hesitate. Thank you for the attention.
Okay, so could you give me a little more detail about sensors? You're using
sensors.
MIRS, right? Yeah. Could you give me a little more detail? Could you give me a little more detail about the sensors?
No. We plan to reproduce the MISR technology using different sensors. So we plan to collaborate with Hyperion Technologies in order to create these new cameras able to obtain the same data, but using a CubeSat constellation. As shown before. Each CubeSat will have its own set of cameras. We plan also to improve the spatial resolution. We have a preliminary design for using 200 meters spatial resolution.
So the original more detailed new camera is right? 200 meters. Is it right?
We adopted the synthetic idea from the synthetic adopted to optic technology.
Related to Naka's question, I'd like to know, do you have the spectral band to measure the weather vapor? If you can monitor or measure the vertical distribution of the water vapor, it is really good for the weather forecasting. typhoon direction monitor forecasting or the hurricane. That is a really hot topics in the United States right now.
Yes, of course. We have also the capability to better understand the wind speed, for example, using the first nadir pointing camera and the last nadir pointing camera, because we have decided to introduce a redundancy in the nadir pointing camera, also due to this fact, because these two camera and the comparison between their data will give us the possibility to obtain also this information.
If so, that I recommend you to work with kind of the meteorological researchers or the weather forecasting company.
And we use meteor forecasting also to assemble the local observation to creating a global map, for instance.
We are just in contact with different and several agencies that asked us this data. So thank you for your suggestion.
I can't see in the description about the thruster injection. How much delta V will be required to construct the constellation?
Actually, we are not performing a calculation like this. However, we think that our CubeSats could be put on orbit, as I mentioned, from the ISS, for instance. Moreover, we can add as another payload for a more bigger satellite for a launch.
As you know, Planetal Lab usually insert is a flock of dose by the injection of the ESS. So we plan to use also the same things, the same way to inject them in orbit, for example.
Well, we perform an analysis like this for in the following steps of this mission. Okay, thank you.
We should have at least one business question. I noticed that you are using Kickstarter as a crowdfunding. Are you looking for additional funding from the venture capitalists?
Okay, we plan to contact also a venture capitalist. Probably it's a good idea, however, because they have a lot of money and we need the money, of course, to support our project. However, we thought at first about Kickstarter, because Kickstarter, as you know, is a very good platform for new projects and people who work on them. Has a very a great sensibility about this project. Moreover, we are in contact with several companies. We are interested in social responsibility benefits, and so they would like to support our project. Also about sponsorship, for instance, to make our project known in the world. So thank you for the suggestion. Okay. If you have any contact about venture capital, you can give us. But thank you so much.
But then
It is one of our idea.
and there will be a conflict with your lifetime requirements.
The first analysis that we have done
we firstly designed for the submission of the proposal a lower orbit, and we remained to this idea. However, you're right. If we finally choose the final orbit that we have exposed before, we have to think for another launch that will reach a higher orbit. You're right. Yes. However, unfortunately we have to save propulsion for the orbit control system.